Okay, so this is a rough draft starting with problem 3, and hopefully I'll be able to work in my new emulator, which I will be showing you in class. Let's see if this fits. This fits nicely. I think this one shows up better than the other calculator. All right, so in problem 3, what is the future value? So if we do our timelines, future value of $925 deposit. I can bring this down a little bit. There we go. Deposited for 1 year at an interest rate of 8%. And our calculator keys N equals 1 year. I over Y equals 8. Present value is equal to 925. We've made no payments toward this, and we're looking for the future value. And the unique thing about these three keys is one of them has to be entered as a negative. So we'll enter present value as a negative because we have no payments and we're solving for future value. So we'll come back to that. Okay, so to finish up drawing up our picture, what we're doing is we're bringing this 925 into the future using the formula future value equals present value times 1 plus I raised to the nth. So in our formula, we know that our present value is $925, 1 plus 0.08 for 1 year. And of course, when the exponent is a 1, it doesn't impact your answer in your parentheses. So this is going to be 925 times 1.08. And then when we yield to our calculators, that gives us an answer of $999. Now, if we go over to our calculator, second, clear work, second, clear time value of money, clear, clear, clear. Told you I'm a little habitual about that, a little obsessive. 1 is my N, 8 is my I over Y, 925 negative is my present value. I'm making no payments, and then I hit compute future value, and the answer is also $999. Now that example will help you work through problems 4, practice problems 4, 5, 6, 7, and 8. Now what I'll do Alright, so this covers problems 4, Alright, so now let's look at problem 6. Okay, now again, obsessively clear my calculator. Okay, so in problem 6, it says how much would be your savings in 9 years after depositing $190 today if the bank pays 9% interest per year. And of course here is, our N is equal to 9 with a 9% interest rate. And essentially what we're going to be doing is we're going to be pulling that 190 over 9 periods to give us the final answer. And we're going to use the same formula that we have been using for all our other problems to solve it. Then with our calculator, we're going to use The N key is 9. The I over Y key is 9. Present value, payment, and future value, we have to decide which one of these we're going to enter in as a negative. So we have our present value of $190 with no payments, and we're solving for future value. So our only choice here is the present value. Payment will be entered as negative. Okay, let's go back to our timeline. So we're looking for the future value. Our present value is $190. So when we add our interest rates, our interest rate for the 9 years in, 1.09 raised to the 9th. And then when we enter that into our calculator, we get 190 times 2.17, and we multiply that times 190, we get an answer of 412.66. And that, of course, is our future value. Then when we do it with our calculator, we say our N is 9, our interest rate is 9, our present value entered as a negative, with no payment, compute future value, we get 412.66, and this covers problems 6 through 7. All right, so now we're going to look at problem 8. And this is a little bit more complex, but it's still not too bad. What we're doing here is a little bit different situation with our timelines. We still have present value and future value. Okay. And it says that a deposit of $440 earns the following interest rate. In the first year, it earns 8%. In the second year, it earns 6%. And then in the third year, it earns 5%. So essentially what we have to do is we have to figure out what this is going to earn between the present value and the future value, pulling this $440 to future value. Now, the thing that's different about this problem is that for a period of time, this is going to earn 8%, and then for the second period of time, it's going to earn 6%, and the third is going to earn 5%. So in essence, what we're going to do is we're going to multiply these interest rates together to give us the right solution. So in this case, we're going to use the future value formula, present value times 1 plus I for the first year. Let's say this is J and this is K, just to keep it simple, times 1 plus J times 1 plus K. And when we do this, we take the $440 deposit, 1.08 times 1.06 times 1.05. And I would recommend that you start with your interest rates. 1.08 times 1.06 times 1.05 times 440 to give us the answer 528.90. And that is the easiest way to work that problem. And this problem covers 8 and 9. Okay, so now we're going to look at problem 10. And basically what we're doing here is we're going backwards. We're looking for the present value. What is the present value of a $270 payment made in 1 year with an interest rate of 9%. And of course, if we use our calculator keys, we have n equals 1, I over y equals 9, present value, payment, or future value, one of those three have to be entered as a negative. So we have the future value, so let's enter the future value as a negative. We don't have a payment, and we're solving for present value, so we'll come back to that. Now, if we rely on our timeline to solve this problem, we're taking this $270 payment and we're bringing it back here to present value. And in this $270 payment, the formula that we're going to use is future value divided by 1 plus I. So here we're solving for, if we fill out our formula, $270 divided by 1.09, which is our 1 plus I. And then when we do that, 270 divided by 1.09, we get an answer of $247.71. We take our n, 1 is our n, 9 is our I over y. We have no present value, no payment, so we're going to enter our future value as a negative number and then compute present value, which gives us $247.71, and our answers match. And this covers problems 10 through 11. All right, so now we're moving right along to problem 12. Now, problem 12 is the rule of 72. And the rule of 72 is basically an easy way to solve for n under the conditions that you're looking for how long it will take the money to double. This is really the only way that you can use the rule of 72. So we call it the rule of 72 because you take 72 as your numerator and you divide it by your interest rate. So in the problem 12, it says approximately how many years are needed to double a $100 investment when the interest rate is 6.5%. So if we take 72 and we divide it by 6.50%, we get 11.08. And this number means 11 years. And then the 08 is 0.08 times 12. So, 12 times 0.08. That gives us less than a month. So it would be, I would say 11 years, 1 month. But the answer for Connect purposes is 1108. And this covers problems 12 through 13. All right, moving on right along here on problem 14. Determine the interest rate earned on a $2,300 deposit when 29 is paid back in 1 year. Okay, so this is in essence using a timeline. This is what we're trying to do. We've got a $2,350 deposit that was depositive, and we know that $2,950 is going to be paid back in 1 year. So we know our n, our n is 1. So what we're trying to do is solve for I here. as far as our interest rate. So there's a couple of different ways to do this. I'm going to show you how to apply the present value formula to it, and then we'll work it through that way. But there are a few different ways to do this. I'm going to stick to using the formula so that we can keep everybody on the same page. So if we use present value equals, let's do this. Let's do future value is equal to the present value times 1 plus I raised to the nth. Now in this case we know that the future value is $29.50 and the present value is $23.50, and we are trying to solve for I. So in this case, the first thing that I would do is I would divide. I'm trying to get I by itself, so the first thing that I would do is I would divide both sides by $23.50, and when I do that, 2950 divided by $23.50, that's going to give me 1.26, 1 plus I, because this cancels out. All right. Then when I take away 1 from each side, it's going to give me 0.26, which is equal to I. Now, in the book, it says that the answer is, or in Connect, it says that the answer is 0.2553. Obviously, I don't have my decimal points set up very high, so let me do that right now. This is a brand new calculator for me. It's not a brand new calculator. It's a brand new version of the BA2 Plus. So what I want to do is I want to do second format, do my decimal points to 6, and hit enter. That should give me 6 decimal points. So when I change it to 6 decimal points, and I go back and I say 2950 divided by 2350, you'll see that I get a much bigger number. Let's ignore this for a second. I get 1.2553 equals 1 plus I. Then when I subtract 1 from each side, I get 0.2553 equals I, which matches what's in Connect. So the difference between the original answer of 0.26 and 0.2553 was the number of decimal points set up on my calculator. And this problem covers 14 through 15. We are halfway through the review. All right, so now let's look at problem number 16. It says consider a $1,200 deposit earning 8% interest per year for 5 years. So here we go. We've got a $1,200 deposit. It's earning 5% interest. Oh, I'm sorry. 8% interest for 5 years. So the first thing it asks us to do is calculate the future value. And so we've done that a million times. So the formula that we're going to use is future value equals present value times 1 plus I raised to the nth. Our present value is 1,200. 1 plus 0.08, that's our interest rate, raised to the 5, the fifth. And then when we do this the long way, we say 1.08, y to the x, 5 y to the x, 1.469328 times 1,200. That gives us $1,763.19 $3,692, which is congruent to $1,763.19. Now, before we go to the calculator keys, it says how much is a total interest earned on this investment. So we basically have to look at the difference between, for total interest, we're going to look at the total value of the asset, which is $1,763.19. And we're going to subtract out what we put in ourselves, which was $1,200. And when we take out the $1,200, we get $563.19. So this is the total interest. Now, the interest that is earned on the original investment is only $96 a year. And we get that by saying $1,200 times 0.08. That's simple interest, principal times interest. So what the $1,200 in simple interest is actually earning is 1.08, which is $96 per year. And of course, it earned that over a 5-year period. So if we take 96 times 5, the simple interest that was earned was $480. So then when we take the total interest of $563.19, which is the total interest, and we subtract out the simple interest, which is what was earned on the original $1,200, what it leaves us is interest on interest, which is $83.19. Now, just looking at this now, this section here, whoops, I need to move this down a little bit so you can see it. Didn't realize I'd run off the paper here. Okay, going back to talking this through, you saw this first part on the original, okay? And so what we did is we took the total value of the investment, which was $1,763.19, and we subtracted out what we put in the bank originally, which was $1,200, which left us total interest of $563.19. Now, if we just look at the simple interest that's earned on the investment, it's earning 8% a year, which is $96. $1,200 times 1.08, $96. Whoops, times 0.08. Take that out. The $1,200 times 0.08 is $96 a year. And, of course, it earned that for 5 years, which gives us $480. This is the money that was earned on the original $1,200. But when we subtract that from the total interest earned, $563.19 minus $480, that gives us $83.19, and this is interest on interest. All right, so now I want to go up to the top part of this problem that we worked through and set it up on the calculator, okay, which we have been doing the whole, we've been doing these on all the problems. So n equals 5, I over y equals 8, present value, payment, and future value. One has to be entered as a negative number. So we have no future value because we're solving for that, and we don't have a payment. So we're going to enter the present value as a negative 1,200. And when we do this, and then hit compute future value, we get 1763.19, which is the same answer we got over here. And this covers problem 16 through 70. All right, so now we're up to 18. Let's look at 18, and I will try not to run off the paper this time in doing this. Okay. Now this one's a little bit different. It's definitely important that for problem 18 we really take a look at the timeline. All right, so it says, what is the value in year 4 of a $690 cash flow made in year 6 if interest rates are 8%? So if we say this is year 6 and it's worth $690, and we know that the interest rate on this is 6%. No, I'm sorry, is 8%. Then all we've got to figure out is what our N is. And so it's asking us for the value in year 4. So for all practical purposes, we're looking for present value in year 4. Okay, so although we usually put present value at this end of the timeline, I'm going to put it right here to keep it simple in our head. So our interest rate is 8%. And then our N is technically 2, right? Can you see that? Now, in your book, it says subtract 6 from 4 is your N. In fact, the formula is going to be written something like, we take the original present value formula, 1 plus I raised to the nth, but then when they work it out, they basically say the present value in year 4 is equal to 690 divided by 1.08, with your N being equal to 6 minus 4. Now when we do this in the timeline, we can see, of course, 6 minus 4 here is obviously 2, but in the timeline we can see why that's the case. So we take the present value in year 4, 690 divided by 1.08 raised to the second, 690 divided by 1.08 raised to the second, and I am getting a little bit of a different answer. So let's step this out a little. Oh, you know why? Because this is not 690, this is 670. There we go. All right, so we're taking 670 divided by 1.08. Okay, so that gives us 670 divided by 1.08 raised to the second, 1.166400. 670 divided by 1.166400 gives us a little bit of a different number than what we're getting in the book. Oh, I'm looking at 2 entirely different problems. It is 690. Sorry, 690. I'm looking at this sheet, and there's 2 problems on there. That's one is 670 and one is 690, and it's coming through 2 different ways. So it's 591.563786, 591.56. Now, since we got this one a little bit screwed up, I got this one a little screwed up. Let's work this again one more time so it's clean on the sheet of paper, okay? All right. All right, so we're looking at specifically problem number 18. And when we look at our timeline, which I set up originally correctly, and then I started letting my eyes wander, it's looking for the value of $690 in year 4. This future value is made in year 6, with an interest rate of 8%. And we can see, because we're looking at the picture, that this N is 2. Okay? So then when we go to apply the formula is future value 1 plus I raised to the nth. Now, because we started out with a timeline, we don't have to do any sort of additional calculations to arrive at our n. We just take the 690 divided by 1.08 raised to the 2 to the second. Okay. And that gives us 690 divided by 1.08 raised to the second, which gives us 1.166400. 690 divided by 1.166400 equals 591.563786, which is $591.56. And this covers problems 18 and 19. All right, so now we're going to look at problem 20. And I warned you that if I'm doing this video from home, there's a chance that you will hear my dogs barking. And I think somebody's walking by the house. So I think Sage is getting ready to start her barking. So, but I warned you, if I did this from home, this might happen. Okay, so we have, for number 20, how many years will it take 2 million to grow to 3.8 million with an interest rate of 8%? So again, let's just draw a picture so that we can see what we're doing here. We're looking for n. We're looking for how many years will it take for $2 million of present value to grow to a future value of 3.8 million if the interest rate is 8%. Now, if you'll remember, this is the log problem that or the natural log problem that we worked in class. So we're going to take this step by step so that it's very clear. But this is basically very similar to the problem that we worked in class. Okay, so again, we're still going to use the same old problem or formula that we've been using. Future value equals present value times 1 plus the interest rate raised to the nth. And then when we fill in our numbers, we get 3.8 million, 2.0 million, 2 million, times 1.08, which is our interest rate, and we're solving for n. Now, if we just look at this from a common algebraic situation, we know that in order to solve for n, that we need to get n by itself. So the first thing that I would recommend that you do, and the book may set this up a little differently, but I'm going to walk you through this, and this is proven true through years of working these types of problems, that it's equally effective in getting the right answer. So we'll just step it through, okay? So we're going to go ahead and use natural log to do this, and the first thing I'm going to do to get n by itself is I'm going to divide both sides by $2 million. Okay, and that's going to give me 3.8 divided by 2.0 is going to give me 1.9 million equals 1.08 raised to the nth. Okay, so now right here we need to get the n where we can deal with it, right? So what we're going to do is we're going to take the natural log. This is what I'm thinking, all right? So let me put this right here, thinking. I'm going to take the natural log of 1.08 n, which is this right here, and that's going to be equal to the natural log of 1.9 million. Now, the next thing that I'm going to do is I'm going to move this n right here down to the normal level of the problem, which is going to give me n times the natural log of 1.08 is equal to the natural log of 1.9 million. Now again, what do I ultimately want to do? I want to get n by itself. So here I'm going to divide both sides by the natural log of 1.08, and then that leaves n equals the natural log of 1.9 million divided by the natural log of 1.08 million. And then when I enter it into my calculator, now this is for the BA2 plus, I take 1.9 natural log, and that gives me 0.641854 divided by 1.08 natural log, which gives me 0.076961, and that tells me that when I just divide 641,854 divided by 0.076961 equals, I get 8.33999 years. And when I convert that to years and months, that is equal to 8 years. And then I want 33 or 34% of the year. So if I take 12 months in a year and I just want 34%, 12 times 34, or 12 times 0.34, that gives me 4.08 months. And it's a little different from what was given in Connect. I think Connect ended up with 4.1 months, but that's why I want to see your work. So this is the natural log problem, solving for n, and this problem covers 20 through 22, because I wanted to give you 3 chances to work on that problem. And so now we're moving right up to problem 23. Okay, so in this problem it says, given an 4% interest rate, compute the year 6 future value of deposits made in 1, 2, 3, and 4, in years 1, 2, 3, and 4. So what does that look like? Well, let's start out with our timeline. It says, given an interest rate of 4%, compute the year 6 value of deposits made in year 1, 2, 3, and 4. There was no deposit made in year 5. But if we make it in, the first deposit was $1,900. The second deposit was $2,100. The third deposit was $2,100. And the fourth deposit was $2,400. Okay, so what we're trying to do here is we're trying to find out what the future value is of the total future value of each one of these deposits. So let's start out with this 1900. All right, when we look at this 1900, how long is this 1900 invested for? Well, it's invested for the full 5 years. 1, 2, 3, 4, 5. So the formula for the 1900 is going to be future value is equal to 1900 times 1.04 raised to the 5th. And I actually did this a little bit quirky. All right, I'm doing this a little different from what I usually do on the board. I usually start on the right and come to the left so my lines line up, but this will work okay. All right, so my second deposit is $2,100. How many periods is that invested for? 1, 2, 3, 4. So this part of the problem is $2,100 times 1.04, because the interest rate is the same, over a 4-year period. So N is 5, for this one. N is 4 for this one. Then when we look at the next $2,100 deposit, we have future value. This is going to be N is equal to 3. 1, 2, 3. Future value is 2,100 times 1.04 raised to the third. And then that last deposit that's made in year 4, that is future value is equal to 2,400 times 1.04 raised to the second. Okay. So essentially, as we're setting up this problem, we're taking into consideration that each one of these, all the monies are going to be sitting in the account collecting interest in year 5. So essentially what we're going to do is we're going to add those together. So if we just apply the formula, it's going to be 1,900 times 1.04 raised to the 5th, which is this one right here, plus this formula right here, 2,100 times 1.04 raised to the 4th, plus this formula, 2,100 times 1.04 raised to the 3rd, plus 2,400 times 1.04 raised to the 2nd. So then when we work through each of these, make sure I can see everything here, 1.04 y to the x, 5 y to the x times 1,900. We get $2,311.640515. Now, the only reason why I'm writing all of these out is because your answer will be more accurate if you round at the end. So then 1.04 y to the x, 4 y to the x times 2,100. That gives us 2,456.702976 plus 1.04 y to the x, 3 y to the x times 2,100. That gives us $2,362.214400 plus 1.04 y to the x, 2 y to the x times 2,400. That gives us $2,595.84. And then essentially we're going to add all these together. So since this number, well, let me get this right here. Since this number is already, can't get it somewhere where I'm not covering something up. I've got 2595.84 already in my calculator. Okay, so then I'm going to add to that 2362.214400 plus 2456.702976 plus 2311.640515, and that gives me $9,726.397891, which is congruent to $9,726.40. How did we do? We got it. All right, and so this problem covers number 23 through 24. So now we're off to question number 25. Now, if you will recall, problem number 25 is the problem that gave us the difficulty with the equal sign. So we may run into a little bit of a discipline issue here when we go to solve this problem. Okay, so what we're going to do is, in fact, what I'm going to do is I'm going to step this problem out step by step and make sure that I'm able to set this up right for you the first time.